Hello boys and girls, so in this video we are going to continue our discussion on question 15b. A vessel is giving out 500 Hz, move away from a stationary observer in a direction towards and perpendicular to a flat wall with a velocity of 1.5 meter per second. Determine the frequency that will be heard by the observer. So we want to determine what is the frequency that will be heard by our observer, whereby our observer is a stationary observer. Okay, so I visualize the problem. So we have a moving source. The vessel will be the moving source that emitting the sound of frequency 500 Hz. So the frequency of sound is 500 Hz. And the vessel is moving away from the stationary observer. So I draw the stationary observer here. So the velocity of stationary observer means the velocity will be 0. So velocity observer saya denote sebagai V subscript O. Okay, so the value will be 0. So the vessel is moving with a velocity 1.5. So vessel is the source. So we have the velocity of source is 1.5 meter per second. And this moving source is towards a flat wall. So this is the flat wall. Okay. So in order to solve this question, we have to understand actually what frequency will be heard by the observer. So actually the observer will heard two sound, two frequency. Dia akan dengar dua frekuensi untuk stationary observer ni. So this stationary observer will heard two frequency or it will receive two frequency. One is directly from the moving source. Satu terus daripada moving source. Another one, it will heard the sound or the frequency of sound that reflect from the wall. Reflect from the wall. Okay. So actually for this question, we are going to have two answer. Okay. So kita cuba cari dulu what is the frequency that will be heard by the observer direct from the moving source. So for this one, we are going to focus on this one. First. For the first situation, the frequency that will be heard by the observer directly from moving source. Okay, so I take it out. So I put it here. So directly from moving source. So we have a stationary observer and our source is moving away from this stationary observer. So I take out the equation for Doppler effect. So we have the apparent frequency will be in bracket V plus minus velocity of observer divided by V minus plus velocity of source multiplied actual frequency. So what is the correct sign for velocity observer and also velocity of the source? How we are going to determine? We are going to use the OS method. So our moving source is moved away from our stationary observer. So our source is away, pergi jauh dari observer kita. So we have a plus sign. For the velocity of the source. And then our observer is stationary. It means that velocity of observer is 0. So we can simplify the equations. It will become V over V plus Vs multiplied F. Then only we put in the value. The speed of sound 330. So the speed of velocity of the source vessel is 1.5. The actual frequency emitted by the vessel as the moving source is 500. Okay, so you might pause the video to do the calculations. So if you calculate correctly, you should get around 497.74 Hz. Okay. I hope you get it correctly. Alright. Okay, so that one is the first apparent frequency that will be heard by the stationary observer directly from the moving source. Anyhow, class, jangan lupa selain daripada frequency heard directly from the moving source, actually this moving source is emitting sound. So this sound wave are going to reflect. Dia akan dipantul balik. I use different color. So it will be reflect from the wall. So bunyi tu akan dipantul daripada dinding. So bila dia dipantul dari dinding, dia akan sampai ke telinga stationary observer ni. So we have the second one. So observer will also heard a sound or a frequency after reflected from the wall. So how we are going to determine the frequency heard by the observer after reflected from the wall? Then we are going to focus on the moving source and the wall. Okay, kita akan fokus kepada yang ni lah untuk selesaikan soalan yang kedua. So I put it down, teacher letak di bawah. Okay, so this is the second frequency that will be heard by the stationary observer after the sound being reflected from the wall. So we focus on this one. So we are going to have this situation. So the sound reflected from the wall actually is the apparent frequency between the visor as our moving source and the wall. So now the wall will act as stationary observer. Dinding tu akan bertindak sebagai stationary observer lah, di mana dia akan menerima bunyi daripada sound daripada moving source visor kita. Lepas tu barulah dia boleh reflect balik dan diterima oleh observer kita. Jadi kita perlu dapatkan berapa frekuensi yang dipantul daripada dinding yang setara dengan apparent frequency in between moving source and our wall. Okay, so our wall will act as stationary observer. So kita sekali lagi keluarkan equation untuk apparent frequency. So the equation for apparent frequency is V plus minus V observer over V minus plus velocity of the source multiplied the actual frequency. Okay, so again, we are going to determine the correct sign by using OS method. So now the source is moving towards or approaching the wall. The wall is the observer. So now our source is moving approach, pergi ke arah observer. So source kita pergi arah observer. Okay, source kita pergi arah observer. So apa sign yang kita dapat jumpa? Negative. So maksudnya velocity of the source, tanda dia sekarang adalah negative. And then our wall, dinding ni adalah stationary. So the velocity of the observer is 0. So we can simplify our equation for Doppler effect will become V over V minus Vs multiply F. Then we put in the value. So the speed of sound is 330. The speed of sound 330 minus the speed of the source is 1.5. The actual frequency emitted by the visor, the moving source, is 500. Okay, so you might pause the video to calculate the value. So if you calculate correctly, you will get the value will be 502.28 Hertz. Okay, so it means that The observer, the stationary observer, our stationary observer in this question are going to heard two frequency, which are 497.74 Hertz, which is directly from the moving away source. Another one, 502.28 Hertz, which is reflected from the wall, Okay, so this will be our answer for question 15b. Thank you. I'll see you in next video. Bye bye.